Hello! Today we will look at how to create coastal waves. To do this we need the distance to nearest surface function, the noise function, a couple of textures from the starter kit, and a bit of imagination. An example of such material you see now on the screen. In the description of the video I will leave a link to the text version of the lesson. Also using this link you can download the source code of functions and material. Let's start by preparing the project. First of all, open Project Settings, turn on the Generate Mesh Distance Fields option, and reload the project. This is necessary for the correct operation of the distance to nearest surface function. Then open the World Settings tab and set the drawing distance we need to the Global Distance Field View Distance parameter. We need to select this value based on the size of our area, because if we set too small value, the waves will break off sharply. And if we set too large value, then quality will suffer. We will apply the material to the plane that serves as the surface of the ocean. The distance from the bottom of the ocean to the surface should be sufficiently large. Otherwise various artifacts may appear of the entire surface. We will have a parameter that allows us to adjust this distance. But since it's closely related to the distance at which coastal waves begin to appear, you need to pay attention to this. Let's see what the global distance field, which is used in the function distance to nearest surface, looks like. It should be noted that if there is nothing on the scene except the landscape and the plane, let's hide this sphere, then the global distance field may behave a little strange. But after some other object containing static mesh appears on the scene, everything returns to normal. Let's discover our material. Blend mode is set to translucent. The surf area block is responsible for the size of the surf area and transfers a gradient to the mfsurf function. The gradient changes from 0 to 1. The boundary of the appearance of waves corresponds to 0, and the coastlines corresponds to unity. The distance parameter allows us to adjust the distance from the coast to the border of the appearance of waves. In fact, it determines the area of the surf. Let's see how the distance parameter affects our material. The base color and foam color parameters determine the color of water and foam, and the opacity parameter sets the transparency of the material. Let's open the function mfsurf. It contains all the basic logic. A gradient is passed to the input of the function, and a wave system is obtained at the output. The global noise block is responsible for the global wave distortion. The parameter global noise scale is responsible for the scale of these distortions. The parameter global noise power is responsible for the strength of these distortions. The noise node allows us to configure noise parameters. The settings we are using are now visible on the screen, and the Use Global Noise switch allows us to enable and disable this block. Let's see how the waves look without using global noise. And also pay attention to power and scale. The time block is responsible for the movement of waves. It's added to the global noise block and passed to the input of the mf forward waves and mf reverse wave functions. Parameter wave speed allows us to adjust the speed of the waves. The local noise block is responsible for the local wave distortion, that is foam and small inhomogeneities. The local noise scale parameter is responsible for the scale of these distortions, and the local noise value set parameter is responsible for the strength of the distortions. The texture sample node allows us to select the texture that will be used for local distortion. The use local noise switch allows us to enable or disable this block. Let's see how the wave looks without using local noise. And also pay attention to scale and offset. Let's open the function MF cosine gradient. It converts a linear gradient into a piece of its sinusoid that allows us to get smoother transitions near 0 and 1. We open the function MF forward waves. It's responsible for creating waves running towards the shore. The number of waves block sets the number of waves, the direction of movement, and also adds global distortion at in changing position over time. The forward waves block calls the MF waves function and sets the parameters of the forward waves. The function MF waves and its input parameters will be discussed a bit later. The use forward wave switch allows us to enable and disable forward waves. Let's see how the material looks without using of forward waves. And change number of waves. Let's open the function MF reverse wave. It creates a wave running from the coast, determines the size of the region in which this wave propagates, and calls the MF coastline function, which creates foam near the coast. The reverse wave area block defines the area in which the reverse wave propagates, and also sets the direction of movement and adds global distortion. The reverse relative distance parameter determines the relative distance over which the reverse wave will propagate. The reverse wave time offset parameter allows us to change the moment when the reverse wave appears. If this parameter is equal to 0, then the reverse wave appears immediately after the forward wave hits the shore. The reverse wave gradient parameter will determine how quickly, at what distance from the coast, the reverse wave disappears. The reverse wave block calls the MF waves function and sets the parameters of the reverse wave. The function MF waves and its input parameters will be discussed a bit later. The use reverse wave switch allows us to enable and disable the reverse wave, and the use coastline switch allows us to enable and disable the foam near the shore. Let's see what the coastal zone looks like without using a reverse wave. Now turn off the foam, turn on the reverse wave, add foam and forward waves. If we set the time offset equal to 0.5, then the reverse wave will appear in the gap between the forward waves. Open the function MF coastline. It's responsible for creating foam and water movement near the shore. The time block is responsible for the speed of the foam near the shore. This speed is controlled by the parameter coast noise change speed. The coastline area block defines the area of foam formation and its brightness. The coastline gradient parameter determines at what distance from the shore the foam disappears, and the coastline power parameter determines the brightness of this foam. The coast noise block is responsible for foam simulation. The coast noise scale parameter determines the extent of the distortion. The coast noise power parameter determines the strength of the distortion or blurriness of the bodies, and the coastline value of said parameter allows us to change the contrast. The noise loop block makes foam behavior periodic. Let's see how speed, power, and scale affect foam behavior. Finally, we got to the MF waves function. It's responsible for creating the waves. The direction of motion, the number of waves, and the other characteristics are determined by the input parameters. The wave front relative width parameter determines what part of the wave is occupied by its head, front part of the wave. The wave front power parameter determines how bright the front of the wave will be, and the wavefront gradient parameter determines how sharply the brightness of the front of the wave changes, blurring of the front body. The wave body power parameter determines how bright the body of the wave will be, main part of the wave, and the parameter wave body gradient determines how sharply the brightness of the main part of the wave changes. The base wave block turns the input gradient, which lies in the range from 0 to n, where n is an integer, into n gradients from 0 to 1. In essence, it creates basic waves, if the result of this block is immediately passed to the function output. Then we get this picture. Let's put everything back in place. The front block is responsible for the front of the wave. It determines its size, brightness, and blurring of the bodies. The body block is responsible for the main part of the wave. It also determines the size, brightness, and blurring of the bodies. Well, we reviewed with you all the functions that are involved in creating the material. Let me remind you again that the text version of the lesson and the source code of the functions can be found at the link in the description. And that's all for today. Like it if you like the video. Subscribe to the channel. See you in the next video.